Okay. All right. So I've got, I think I planned for about maybe a 90-minute talk, and we're going to try to squeeze it into to 55 minutes here. So I will probably skip over some demos and kind of move through. We'll try to move quickly and give you some time to get to the buses and everything. My name is Matt Steele. I'm not on a product group. You guys have heard from a lot of folks today who are in the various product groups. I'm out in the field. I'm a partner, an ISV developer consultant, and work with a number of our larger partners. We have a practice here, so it's not an evangelism type role. It's partner services, so the partner is actually paying for support. And a lot of the partners I work with around Office 365, a number of them are building large-scale Exchange Web Services based apps or services. In this case, what I'm going to share is just some learnings from working with a few of those partners who are building large-scale service-based applications that are monitoring mailboxes at scale. So they're retrieving notifications. We'll talk specifically about streaming notifications. If you were at this event a couple years ago, I did a session very similar to this, based around Exchange 2010 or Wave 14 in Office 365. This is kind of an update for that. So as a disclaimer, and especially since we're on a bit of a time crunch here, I'm not going to go into a lot of background unless we get questions, and I'll kind of keep it on the topic of kind of what's new or what's different in Wave 15, Exchange 2013. So there are some assumptions here. There's links in this deck here to my previous sessions from the previous Plugfest, which kind of give a basic background of basic Exchange Web Services operations. Some of that you may have heard this morning, but you can always go back here and take a look at that. So the main agenda for this talk is really to introduce some key server role changes in Exchange 2013 Wave 15 that affect how we, as an EWS-based service or application, create affinity and where we need to create affinity with back-end Exchange servers. So, we'll talk about that more. It's mainly at the mailbox role. We talked about it in Wave 14 timeframe, and that was going through the load balancer. We'll talk about how that changes in Wave 15. And that's basically around routing hints, which we'll talk about, and then we'll kind of put that all together in the context of taking a look at subscriptions, specifically streaming subscriptions in Exchange Web Services, and how you put all this together at scale. All right, so if we look at the server role changes in Wave 14, and my little animation here is a little bit out of sync, but in Wave 14, what we had is basically, the key thing to note here is we have SOAP in the case of Exchange Web Services client talking to a CAS role, and the CAS role digested the SOAP. It understood the protocol and talked RPC to the mailbox server. Basic thing, key point here is in 15, the CAS is just passing through. The CAS is not protocol specific. It does authentication, a few other high-level things. It doesn't get into the protocol. It doesn't break down the SOAP XML. It just passes that along to the mailbox server. And we'll see how that impacts like a service-based application that's doing things like impersonation, or an application that's trying to keep track of subscriptions to multiple mailboxes. So this is a slide that I took straight from Ross Smith and kind of stole it, and I'll play a joke on it later. But basically, there's a key to enlightenment here, which is the CAS just passes off requests across protocols to the mailbox server that has the active database copy. So each CAS determines the right endpoint for the traffic, and for any given mailbox connectivity, the protocol is always served by this mailbox server that is hosting the active copy. I'll quickly show where we don't really want that to happen. with Exchange Web Services and what we can do about it. So what we can do about it, we can help the CAS and basically override that basic logic in this previous slide with what we call routing hints. So I'm going to skip over this demo and talk and basically just talk through it and introduce the scenario of, we're talking about service-based application, not a client. We're not talking about Outlook for Mac or something that uses EWS. This is any number of a high-scale service application that's maybe monitoring several thousand mailboxes to provide data back to a set of mobile devices that are highly secured. You can guess a couple of people out there who do that. What you're doing in that scenario is you have a service account. In this case, we've got a service account here that's on Mailbox Server 2. If I'm that service account and make a simple EWS request based on the slide we were just showing, the key to enlightenment, every EWS request that I make as service account 2 is going to go to the mailbox server where a service account lives, which is Mailbox Server 2. Okay. With EWS, though, I can introduce a wrinkle to that. If I'm a service application, I may want to impersonate account, right? So as service account, I'm authenticated against CAS as service account, but I'm actually accessing user 1 who lives on mailbox 1. So what happens in this case is there's no error that's returned back to the client. Exchange will figure this out. The CAS passes the request down to mailbox 2 because service account authenticated. However, inside that EWS request, there is a request to impersonate user 1. So mailbox 2 says, you know what? I can't handle this request. I need to proxy this request to mailbox 1. So you're introducing an extra hop here based on the basic rules of routing here. So what we need to do, and actually I'll show you this here. So if we look at this, these are the headers, the HTTP headers up here. This is what the CAS role knows about. Down below is what the mailbox role knows about. And this, if you can probably see that or see it close enough, is the SOAP header that indicates the target mailbox. So that's a key point there, in that the CAS role doesn't know who you're impersonating. So I'll cut over here to a demo. And what we'll do just very quickly, so I'm going to run a demo here. I'm just making a simple find item request, and I'll zoom in on this a little bit to show you. Simple find item request as a service account. So you can see here, I'm impersonating user 1 as service account, but my request is going to server 2, Exchange Server 2. So my service account is on Exchange Server 02. This user 1 is actually on Exchange Server 1. So it's that previous slide that I just showed is what's happening here. I am proxying the request from server 1 to server 2. So to get around that, if I could get my mouse back over here. There we go. So to get around that, we have the concept of routing hints. And this is your application taking ownership of where the target mailbox server is, or where to route the request. So you're basically overriding the default logic here, and you're going to say, this is where I want you to send that request. So basically what you want to do here is you want to say, even though I'm authenticating a service account, I'm going to set this X anchor mailbox HTTP header, so an HTTP header with the SMTP address of the target mailbox. That tells the CAS, so the CAS, remember, isn't protocol specific. The CAS picks off that header and routes the request to mailbox 1 directly, so we don't have the extra hop. So these are kind of the basic rules of CAS routing and basically overriding the default routing. So by default, authenticated user. The second step would be is if there's an anchor mailbox header set, and then it will pick off that SMTP address, resolve where that mailbox's backend server is en route to that mailbox. The last one is prefer server affinity, and this is key for streaming notifications. It really only applies to that scenario, and we'll talk about that in a minute. That actually will create affinity with a specific backend server, not a specific mailbox. We'll talk about why that's important. So again, anchor mailbox is mailbox specific. So if I make a request for user 1 here, and they're on mailbox server 1, and then they move to mailbox server 2, my next request is going to go to mailbox server 2. And that's a good thing when we're doing impersonation. We want all the requests for that mailbox to follow it. We don't want to be server specific and get stuck on some server and end up proxying again. So this diagram here it's basically a demonstration of what goes on here. As the light green is the first request, and then you have the second request after it moves. So when to use anchor mailbox. We talked about impersonation. Another scenario that's very similar to that is delegate access. So that's not when I'm impersonating user 1 as service account, but when I've been explicitly granted permissions to it. If you're viewing someone else's calendar, that kind of is a client scenario, not necessarily a server scenario. If I'm copying items between mailboxes or moving them, you want to make sure that your requests are going with the source mailbox and not going to the target mailbox. And then there's a lot of different requests, and this is something that in Exchange 14, Wave 14, it wasn't as big of an issue, but when we put all this in perspective of working across multiple mailboxes, you can issue requests like find item or get folder across multiple mailboxes in a single request. You can issue multiple IDs that don't all have to be in the same mailbox in a single get item request. With the way that we route through the CAS and then these requests end up at a single mailbox server, you want to actually not do that as much anymore. So you want to prefer to, even though the protocol allows you to do it, the preferred way to get best performance would to keep a single request within the context of a single mailbox and create separate requests for multiple mailboxes. In 14, that worked better because the CAS server could make RPCs to different backend mailbox servers. We don't do that anymore, so you'll create a lot of proxying on the backend. So going in deeper to prefer server affinity. So this is server specific. So this is a scenario where when I'm using the prefer server affinity request, when user 1's mailbox moves, my requests continue to go to mailbox 1. So this is me saying, I want to create affinity with mailbox 1, and then when user 1 moves, I want to keep going back to mailbox 1. And we'll talk a little bit about why that's important here on the next slide. So in the case of streaming subscriptions, we create subscriptions. When you subscribe, you're creating a subscription that lives on the backend mailbox server, and it actually lives in memory. We'll talk about that too, the basic effect of that. What happens here, and what we want to do is we want to make sure that we get back to the correct backend server that has the subscription table in it. So in this previous slide, if user 1 moves, mailbox server 1 is the server that has the subscription table that knows about the subscriptions I'm creating. We want to make sure we get back there. So I'll go into this visually here and kind of compare it to where we were with Wave 14. So this is a slide I used in Wave 14. If you have an EWS app that's going through a load balancer in Wave 14, you had an Exchange cookie, and you basically ping-pong that back and forth for all of your requests. And that would create affinity between you and a CAS server. In Wave 14, the subscription table and all the subscriptions that you used were stored on the CAS server. And so you basically just use this exchange cookie to get back to the right place. In wave 15, this is different. So I use basically my subscription table is now on the back-end mailbox server. I've got multiple subscriptions that I'm creating here. So the purple line is my initial subscription. The green line is another subscription. And then I do a single get events call across multiple mailboxes to get events from all these subscriptions I create.
What is
Exchange 2013. And
after the service pack changes, RGB, or?
this is Exchange 2013 RTM. Yeah. And this is Office 365 Exchange Online today. Yeah. So what happens here is I'm essentially making two calls. I subscribe and then I get events. Okay. So I'm going to monitor multiple mailboxes with a single get events call. So I'm going to create multiple subscriptions, in this case monitoring mailbox 1 and mailbox 2. So the way this works in Exchange 2013 is my first subscribe I make with that X prefer server affinity header. That request goes maybe to CAS 1 because I just have basically level 3 load balancing going on here. So first request ends up at CAS 1. CAS 1 says, okay, I'm sending that to mailbox 1. So I've set prefer server affinity. I've set my anchor mailbox to mailbox 1. That gets my request here, regardless of where my service account is. On the response back, I get a cookie. It's called the X backend override cookie. And that cookie I resend with all my subsequent requests. And we'll see this in action too. So on my second subscribe to mailbox 2, I want that to also go to mailbox 1. And then I want all my subsequent get events calls to go to mailbox server 1 too. So I send this cookie back. The cookie, so this request with the cookie, with the X anchor mailbox header, and with the prefer server affinity header, hits CAS 2. CAS 2 looks at that and says, according to our rules here, which I lost. According to our rules here, it works down and it sees, okay, I've got the prefer server affinity header. I've got a backend override cookie. I'm going to basically shortcut this and send it to mailbox server 1.
CAS will say that, right?
The CAS will say that because it's all HTTP header and cookie based at this point. There's nothing protocol specific here. So now we have an interesting situation because mailbox 1. So user 1 here, the purple user, is on mailbox 1. The green user, our second subscribe, is actually on a different mailbox server. Supposedly, if you remember the key to enlightenment, is that all the requests for a given mailbox will be served by the mailbox server at the protocol level, and there won't be any kind of cross RPC traffic that we saw in Wave 14. As far as I know, this is the only case where we just flat out break that rule. So there's actually a request that goes between mailbox server 1 and mailbox 2 when my red request here, the get events request, comes into mailbox 1. That EWS request needs to be handled by mailbox 1, but it needs to get events from mailbox 2. So it actually does make a lower protocol and makes an RPC call between the two servers to get events back and then return the response from mailbox 1 back to my client. Any questions about that? Does that make sense? So the key thing here is that I can't use the X anchor mailbox header to always get me back to mailbox 1, mailbox server 1. I've got to use this X prefer server affinity in the backend cookie to get back to where my streaming subscription table is. So these are all new cookies and headers and kind of logic that you would use for a Wave 15 server if you're supporting Exchange Online. Very different from what you did in 14. So what you did in Exchange 2010 is not gonna transfer over here. And we've seen a lot of confusion about this in the field, and especially just taking apps, move them over. So looking at this more at scale, and let me go back and I'll just introduce one more point about this blue line here. So these RPCs that go back and forth. If these two mailbox servers are in different AD sites, we won't make a cross-site RPC. So this is going to happen more in the service than anywhere else. We'll see why that's important. So essentially, this red call here, if mailbox 1 and mailbox 2 are in different sites, the red get events call to mailbox 1 will fail, and it will basically say it can't proxy this request to the other server, and you'll get an error back. So for subscribing at scale, we're in a scenario where we have, say, 10,000 mailboxes that we want to create subscriptions for and get events from. The first thing we need to do is we perform auto-discover on each of these mailboxes. From that, we get an external EWS URL, which is where we'll make requests to. And then the second piece of information we'll get is grouping information, which is essentially the AD site. It's just literally just the AD site that mailbox is currently in. What we want to do is take this list of 10,000 or so mailboxes that we're monitoring and break them down into groups based on a concatenation of that EWS URL, which is going to tell you the difference between essentially an on-prem user and an online user. They'll have different EWS URLs, obviously, and then the grouping information within those large groupings who are in different sites. So for any given Office 365 tenant, I've got a demo tenant with 25 users in it. I've got about 5 different grouping information values that come back. So I can't put all of those 25 mailboxes into a single get streaming events request. So this is a very important step. You can use get user settings to retrieve, basically you don't have to do one auto discover per every 10,000, each 10,000 mailbox. You can group them together as a best practice. So first step is break down your group of mailboxes by this information. So once we do that, we want to further break down these groups into groups of no more than 200 to 250 mailboxes each. So I've broken them down by external URL, and maybe got my on-prem and my online users separated, and then I further have them broken down essentially by AD site. I want to further break down groups so there's no more than 200 to 250 in each group. From that point, those are the groups that I'm going to use for a single get streaming events call. So I'm going to go through in my next step, and I'm going to, for each one of these groups, designate an anchor mailbox, which is essentially just going to be the first mailbox in each group. It doesn't really matter what it is. If you look back, think back to that graphic I was just showing, this is just the mailbox that the first request is going to go to that doesn't have that backend cookie. Then you'll get the backend cookie and you'll resubmit that. So you'll set the X anchor mailbox header, and you'll set the X prefer server affinity, set that to true, and your anchor mailbox will always be the same, but eventually you'll just be using the cookie instead. From here, you go through and you subscribe to each mailbox. So using impersonation, you've set your SOAP header to impersonate the target mailbox. So each one of these mailboxes that you're subscribing to, you set the anchor mailbox to be what we specified in the first step. So each request in a given group will have the same anchor mailbox. In this step, the target mailbox, the one you're subscribing to, will be different for each request, and the preferred server affinity will be set to true. Again, the first subscribe establishes the X backend override cookie and the server-based affinity, and all subscribes within that group will end up going to the same mailbox server. In the next step, you'll do a get events request. It's a get streaming events request. You'll basically package up all the subscription IDs tied to all the mailboxes in the group that you've created. You'll issue one request. You'll impersonate the anchor mailbox and set the X anchor mailbox header to the group's anchor mailbox, which is less important because you're really using the prefer server affinity, which is set to true, and all your requests will go there. And then what you want to make sure that you do in most APIs, if you're using the EWS Managed API or the EWS Java API that we supply, and a lot of just HTTP web requests, API sets and various different platforms will just reissue cookies. So kind of dependent on that, you may or may not have to really worry about sending the backend cookie over again. But what you want to do is make sure that's set, but then also set the X prefer server affinity to true in all these requests, so that the CAS will look at that prefer server affinity header before it even looks to route by the backend override cookie. So that's how we get to this point where we're routing requests to mailbox 1 repeatedly. Even if our target mailboxes move, we find our way back to the active subscription table. So some considerations here. Throttling limits, which I've talked about in previous sessions. Basically, impersonation and using impersonation is a great way to avoid those throttling limits. What you do, basically the way we apply throttling with a service account impersonation scenario is any of the connection limits or subscription limits are decremented against the impersonated user's throttling budget. So they basically have like an interactive budget for client connections and then a non-interactive budget. So it's a copy of the same budget. If you have the default is 20 concurrent EWS connections on a given mailbox, you can have 20 from an active client, so that's not using impersonation, versus a non-interactive client, which would be a service using impersonation. So when they're impersonating, it's counting against the target account's budget. So a given service account can make n number of impersonated requests to different mailboxes.
Is that what drives the 200, 250 limit?
The 200, 250 limit is actually it's actually the load that you're putting onto the backend server so it's one get streaming events call, and you're saying get streaming events across 200 to 250 subscription IDs. So you're telling that server to go out and get that information. So you're actually impersonating just one account there. The reason that we don't go beyond that is more of just it's not a hard limit. There's no error if you go to 251. It's just that's a good balance between bundling subscriptions into a single call and then putting stress on the server and not getting events back in a timely manner. So I talked about the multiple Active Directory sites. This is definitely true in the service. It also can be true in on-prem. If you think about it, what we're trying to avoid here basically is doing that blue line RPC again across like a AD site that's got some kind of geographic designation. So if I've got an East Coast data center and a West Coast data center and I had some kind of mailbox failover, I don't want to do this blue RPC between mailbox servers, across, a low latent connection or something. So we basically use that designator. You'll get an error back that says proxy request not allowed. I'll show you what that looks like in that case. So be cognizant of that. The way to avoid it is to use this grouping information. If you have a mailbox move and you get one of these requests, you simply go back and you do perform auto-discover for the target mailbox that you got the error about, and you find out from the grouping information what AD site that they moved to. It's usually one that you already know about. It's just a matter of taking that subscription or that target mailbox and moving it to a different group and moving forward with that in the other group. Another consideration is the subscription table. Again, so this orange table here where I'm building out these subscriptions in memory on a backend server. This is stored in memory. It's not stored in the mailbox. It's not stored on the server. If there's an IIS reset or the app pool gets recycled on a regular maintenance job, if the server gets unplugged, whatever, you're going to lose your subscriptions. You're going to have to resubscribe. In the service, this happens, I think, every 48 hours. We do an app pool recycle. So you'll see this happen quite a bit, actually, in Office 365. The other scenario where this might happen is Well, I guess this more towards like the Active Directory site. So when we do upgrades in the service, we do them within a DAG essentially. So we'll upgrade a server and then we'll fail over the database to the updated server. And so anytime we have a mailbox database failover situation like that, it's almost always between sites in the service. So you'll get both of these last two at least once a week in the service. And it should be, I mean, it should be expected. This should be something that your app can handle. There's very clear errors and scenarios for how you recover from that. So before I get into some demos here, I just want to introduce kind of the test environment that I'm going to do these demos within. Basically what I've done is set up using Azure. I'm just using IaaS and Azure to set up virtual machines, create a couple subnets, 2 domain controllers, one in site A, one in site B, 3 Exchange servers. So I've got 1 Exchange server in site A, 2 Exchange servers in site B. Key there is just to show the difference between moving mailboxes between servers within a site versus cross-site. And we can get into some different error scenarios. So this kind of testing environment, very simple, but kind of run you through all the functional scenarios that you would want to test if you're trying to do streaming subscriptions at scale, even against the service. And this is all, these are all Exchange 2013 boxes here in the environment. So let's just take a quick look at that. Any questions at this point? Everybody's ready to get to the company store and get to dinner. So again, this is all running in Azure. As a plug for Azure, if you have an MSDN Ultimate account, you get $150 worth of credit a month. I've had this environment set up and running since the beginning of the month, preparing for this lab. I've got you get a nice estimate here of based on all the crap that I have running in my Azure subscription here. I can keep going with what I got for another 15 days, it says. Which is pretty good because we're at the 17th now, so I should get through the month. But I can pause this environment, stand it up, use it when I need to. I can automate it all with PowerShell. So basically, here are my DCs, my Exchange servers. They're all running. The one thing I'll show you here under networks is I have my network set up here. It's the Blue Steel network if you're a Zoolander fan. And you can see I've got the different, that's a better view of it. You can create with virtual networking in Azure, it's very easy to create subnets. So I've got a few subnets there. So that's basically how I created that. Very simple and straightforward in Azure.
So you're hosting your servers in the Azure cloud?
Yep. Yep.
Do you manage them yourself?
Yep. Absolutely.
So why do you say, so you tested against that?
That's what I'm testing against. Yep. So I can test against Office 365. But what I want to do in these test scenarios is I really want to control the mailbox moves and the cross-site stuff. So yeah, so what I would recommend that you do is take this an environment like this, and honestly, it doesn't matter to me whether you use AWS or your on-prem stuff or whatever, but use this to really test these targeted scenarios of mailbox moves or site, AD sites and things like that. You can't control that in Office 365 if you have a tenant, just a test tenant. You can see it, but you can't trigger the moves and whatnot. It's interesting to do some testing with Office 365 too, and discovering how often things like these IIS resets and app pool recycles happen, how frequently that happens. So the purpose of this is a very controlled environment for these scenarios. So we can look at just a basic affinity scenario where we want to make sure that, hey, all the requests that I'm making for this given set of mailboxes that I monitor go back to the same same server. So if we look at this, I've got this app running. So basically, I've got a couple different requests here. I'm going to do the first one here, which is a set of subscribes. I'll zoom this in so we can see the results here. We can talk through it. So this is, I'm going to subscribe to user 2 and user 3 using only the X anchor mailbox header. So remember, user 2 and 3 are in different mailbox servers within the same site. All right. So if I look here, I'm specifying, so I've printed out my request headers here. I'm using X anchor mailbox header. I'm not setting prefer server affinity. I've got no backend cookie yet. This request is for user 2 as the anchor mailbox, so it goes to Exchange Server 2 as expected. On the second set, my second subscribe, I'm using X anchor mailbox, set to 2. This is for, I'm subscribing to user 3 though. And actually my impersonation header was wrong here. But so set, even though I'm going to user 3, I've got my X anchor mailbox header set, and so my request goes to the same server. If I was to move, again, this is a scenario where I'm mailbox specific. So if I was to move that mailbox to server 3 or server 1, that request, because I'm only using the X anchor mailbox header, that request would follow the mailbox. So on this next example, I'm going to use the backend override cookie. So you can see on the first request here, I've got X anchor mailbox set to user 2, but prefer server affinity set to true. I don't have a cookie yet. I get that cookie from the server. So my first request has no backend override cookie. In the response, I get that backend override cookie, and on my next request, I resend it. So it turns out this isn't the best example because I end up, well, you can see the use of the backend override cookie, but you don't really notice a change in behavior here. The requests still end up going to mailbox server 2. The point is that no matter where my anchor mailbox is now, no matter where user 2 is, this backend override cookie is explicitly forcing these requests to a particular server. If I didn't have prefer server affinity set to true here, even if I was resending that backend override cookie, it has no effect. So you basically, by controlling the headers and replaying the cookies, you can control where the requests go. So let's look at a cross-site scenario. So this is, I'm going to subscribe, I'm going to try to subscribe using, if we go back, let's just take a quick reminder of our environment here. So basically what I'm going to try to do here is I'm going to try to subscribe to user in one site, and then I'm going to try to impersonate a user in that same site and subscribe to a user in another site. So the green request will succeed, the second request will fail. It's a cross-site call. It's not going to work. All right, so again, you can see I impersonate user 1. So that was that green request that goes into site A. And then I have prefer server affinity set, so I get a cookie back. And you can see in the response header and then in the subsequent request header down here, I'm impersonating user 1. I have the backend override cookie sending me to mailbox server 1. But I'm trying to subscribe to user 2 here, which is in the other AD site. So my request goes to Exchange Server 1, but I get this error proxy request not allowed, one or more of those subscriptions. And this is kind of a misnomer here in the error response here. It says, or another client access server, which basically what it's referring to is a client access role, which is the protocol serving role, which is now on the backend server in 15. So this is a subscribe request that went to the wrong site for a mailbox in the other site and doesn't allow it. If you did a get streaming events request, you would get the same error back if you had one of those subscriptions in that request that went to a mailbox that's now in another site. This is, again, a pretty frequent error that we would see in the service that people struggle with. So now I can show one more thing here. I think this will work here. So basically what I'm going to do is just subscribe to a few different mailboxes here, user 2, user 3, and a user called move me. And basically I'm going to set up these subscriptions, and then we'll just sit back and listen for events. So I've subscribed, and then I've issued my get streaming events call, and so I'm listening for responses. You can see I've got the backend override cookie set to Exchange Server 2. Now I'll mess with it a little bit here. So I'm really just showing you what I'm doing here. I'm RDP'd to my server. I'm on my Exchange Server 2, which I believe is the one that's So basically, what I'm going to do here is I'm going to recycle the app pool, and then I'm going to break my app here. Hopefully, let's do it even worse. Let's see if this. So before I do the IIS reset, we'll just go with the app pool recycle. It should get it on this next call. I should get an error here. And actually, probably what I'm going to get here is a timeout. So when I go back, so there, I got my my connection was terminated there because I did the IIS reset. This may or may not happen in a timely fashion here. We'll see what happens. It should retry the request, and it might not. But basically, this would be a scenario where I've lost that in-memory table. So when I go back and I make my get events calls with these subscription IDs that I've been using, I'll get an error that says error subscription not found. That's Exchange has completely forgotten about these subscriptions I created, so I need to go back and recreate them. And it's not gonna retry in a timely fashion here. Okay, so flipping back here. So just to recap a couple of these test scenarios that were I just kind of walked you through here. A basic subscription affinity test to make sure you go to the same mailbox every time. A test to make sure that you're using the prefer server affinity header, not just the anchor mailbox header. So set up a subscription, be getting events from that, and then move your anchor mailbox to a different server. Your request should still go to the original server because of the prefer server affinity and the backend override cookie. Lost subscription, this is cycling the app pool or IIS reset or just rebooting your backend server. You should lose your subscriptions. You'll get an error subscription not found and resubscribe. The two site tests, we saw that. A site move test, so this would be you move a mailbox within a subscription group to a different site, and you'll get that error proxy request not allowed. And then just while you're doing this, some just kind of lessons from the field and supporting customers here, and some advice on this. So there's certain information that you can get back that we saw in the requests and responses that are particularly helpful. The big thing that I would say is user agent. So we see a lot of partners, they use a unique user agent string, which is great for their app, but they don't put a version number in it. The Office 365 team, the service engineering team sifts through petabytes of data, and we're keeping track of this stuff. We're getting to the point in the service where if your service is interacting with Office 365, we can actually tell that something's broken before you guys can. So in my role, I actually get the Exchange team coming to me saying, this partner's solution is getting this error proxy not allowed, umpteen times a day. And I could reach out to them and tell them that something's going wrong. In some cases, like with that error, I know that they've fixed it in version 2, but I don't know from their user agent string, from what we're seeing in the service, if we're talking about a version 1 or version 2 of their app. So that's definitely a big thing. Also, maybe using a unique user agent between your streaming subscription processes and your just regular mailbox access would help catch that. You can also use this client request ID, so you can provide your own ID for a given request and tell Exchange to return it back to you, so you can correlate requests and responses on your end. You can put that in your logs, and that can be meaningful to you. Exchange doesn't care about it, but we log it. So that can be some bit of information that you send to us and say, can you look at the requests and responses related to client request ID, whatever. And those are unique not to the client app, but unique to the individual requests that your app is making. Then we're talking about sifting through petabytes of data on a very specific search query and can get right to the requests that we're talking about. Much easier than saying, look for user agent Contoso within the time frame of last week and this week across all tenants in 365. It'll take us days to run that query. Another thing that's helpful that you can keep track of in your side and provide to us is 2 response headers that come back. So there's the front end server, XFE server. So that's a CAS that received your request, and then the back-end server. That's the first back-end server to get your request. If it's one of those proxy scenarios, this is not the final server. This is the first server that got it. Nevertheless, it helps shortcut, again, through the petabytes of data down to just the logs for a given server. Helps us immensely. And then there's also a request ID that comes back in the response. So this is a request ID. Unlike the client request ID, this is a request ID from the Exchange side, so it's one that the service knows about. And so that is something that you can log in your requests as well. And then that can correlate between your request ID and the one that we're capturing and help with debugging. So at this point, and I'm actually a little early, got about 5 minutes left. Anybody have any questions about that? There was an immense amount of material if it was not something that you've been through before. So any questions about that? Any concerns, anything else? All right. Great. Thank you very much.